is Sean Coleman, and I'd like to talk to you a bit today about building and integrating frameworks. I work at Possible Mobile, and we do a lot of apps for really big brands like JetBlue and Turner and a bunch of others that are super secret that aren't up there. And so the nature of these apps is usually they have lots of lines of code. So these are big apps, a quarter of a million lines of code often. They have several targets. They usually have watch extensions and today extensions and things like that. So in the course of making these types of apps all the time, our teams, we integrate lots of frameworks. Some of them you know about. Some of them are the nice citizens like hockey, and then some of them you're less aware of. So I'd like to give you a brief background on my programming history. In the 80s, my parents bought me an Apple II GS, and I played adventure games, a lot of them were text-based, so you type go east, and task times in Toontown would go east. And so out of that, I started making my own little text-based adventure games, and they'd have these eloquent descriptions of rooms, and you kill dragons and things like that. And after that, years later, I went to Florida State University, and I got my first job writing COBOL, and that was quite the experience. That pretty much concludes my all caps programming languages. Next, I joined a flight simulator company, and I wrote some C++. We wrote a middle tier layer that did kind of raw networking with UDP sockets back and forth between flight controls and the display system. I spent a little time in Microsoft land. And then I did some Python, like data munging, collaborating with statisticians, and using NumPy and things like that. And in that sort of same role, we also did web work. And I sort of got bit by the Rails bug when Rails was starting to, actually after it had already been popular, I became more aware of Rails and Ruby, and I wanted to write Ruby in Rails, and that's what I did. And I encouraged my team to do the same, so we basically built kind of a small Rails shop. When I was writing Rails, we bought MacBooks because that's what Rails people do, and then I became aware that I didn't know how to use Xcode, which felt really weird because I was very familiar with Visual Studio, so I needed to learn the Visual Studio equivalent. So I started playing around with Xcode, and eventually that wound up in building a small app for that company that I kind of started. It was an education-based app, and so I got kind of hooked on iOS, and I've been doing that since. If you overlay some times and some other things, they pretty much get a snapshot of my life since the 80s. Now that we know each other quite well, story time. So let's say we are working with a client, and they're interested in bringing in a framework called Super Engagement Tracker. This framework's really exciting. It's going to track your users, wherever you go across channels. And so we make contact with the Super Engagement Tracker team, and we ask, where do we get your framework? Where do we download it? And they say, don't worry, an email's coming. So we get like this self-destructing, message. It's basically an email that points to a link on the web that's one of these types that, goes away. It expires in 3 days. So we're like, oh, this is exciting. Mission Impossible. And so we go to a link and build this framework in our app. And we get lots of warnings like could not resolve external types. So we do a little research on this, and we find out some of the background about some build settings that have to change. And we give that back to Super Engagement Tracker team, and then they work with it. So F-bomb, right? Like first failure. So they give us a new link to a message that will expire, and we try to link it, and this time no headers. So somehow between version previous and this version, they've managed to do the same, build the same framework, but they forgot to stick the headers in it. So F-bomb. And we write them back. We say, there are no headers, and we need headers. And so the next problem we encounter is duplicate symbols after another set of email exchanges. And so what they've done is they've packaged the same XML parsing library that another framework that we import also builds in and links in. And so we have these duplicate symbols coming up about XML. So we explain the situation, we email both of those bidders, and eventually Super Engagement Tracker gives us a new version. And in this version, somehow between the previous one and this one, they've changed the deployment target from 8.0 to 9.2. So our app supports 8.0 and above, so that's a big problem. Another round of emails. So now we're getting closer, right? We can compile and link at this point, but the properties in the header files are missing storage modifiers, like where they should say strong. There's nothing. Then Objective-C throws a bunch of errors, like it's going to default to a sign. So that's undesirable for us because we run a clean building project, right? We have treat warnings as errors on the project. So this is a little harder to push back on. And at this point, they're like, hey, it's good enough. You guys are good. But we're saying we don't want to compromise the integrity of the entire project for your framework. So we push back. Finally, we're building and linking cleanly. But at this point, we noticed that the header file that they provided is kind of like the only source of good documentation. And it's not that good, right? It's like, you have methods listed with rough descriptions, but each parameter isn't described like what we should pass in. So that's not good. So we end up doing a bunch more email exchanges to actually discover how to use the framework. So after 64 emails over the course of a month, we're finally at a point where we can integrate their feature. And this is what I call email-driven development. We're programming at the speed of business right now. And this is not how we want to operate. And we usually notice that this happens from shops that the synergy to engineering ratio is very high. So these shops are very focused on the business aspect, but they have these tiny engineering departments. And so this is probably one poor person, doing all this work and having problems. And they probably don't have much control in place or anything like that. So I have something to share with you. This is a true story. I made up the name Super Engagement Tracker, but the rest of it is absolutely true. So my colleague Ada Turner and I, we were feeling this after integrating, three or four frameworks this year that are this type of quality, and we decided to do something. So we wrote a series of articles, and the first one kind of culminated in a checklist that we call the Seaworthy framework checklist for vendors. So this is a series of items that we feel is important and things that we'd like to see from vendors when we integrate frameworks. So I'll go through some of these and I'll skip over some as well. Provide a sample project that builds cleanly. The sample project and the framework do not require third-party tools such as CocoaPods. We enjoy having the option of CocoaPods, but we don't really want to see it imposed. So we want to see manual installation option. The sample project is written in Swift. The framework is built with the latest non-beta version of Xcode. The framework provides configurable debug log levels with the option to completely silence them. So we like to have control over our console of our Xcode project. That's our place, right? That's where we put our debug messages. And if the framework we're linking comes online and it says, Super Engagement Tracker 1.6 engaged, every time we build and run our project, we feel as if they're kind of getting in our space and making it muddy. So we really don't enjoy that. The framework has a small memory and on-disk footprint. If the framework that we're linking has an idle memory usage of say 5 megabytes or more, and we're building in lots of those, we're getting pushed closer to Watchdog before we've even really done anything with our app, and that's not good. At the same time, we'd like to not use up our users' cellular bandwidth when they pull down our app. The framework has been tested with all the deployment targets supported. The framework supports bitcode, which is hopefully not a concern soon, but right now it kind of is. The framework doesn't swizzle system API methods. The NS Hipster article on swizzling is kind of fun because it cites the framework's yeah song, and it's like if you could destroy the world at the click of the switch, would you do it? And that's kind of like referencing the power of swizzling that you probably shouldn't abuse. Now I will abuse swizzling in my app. I'd like to, please don't push that on me. Swizzling, if you're not familiar, is where you kind of hijack system methods and provide your own implementation implementation, so you're layering the functionality. We like great comments that are doc. We love the Xcode information that provides. And we like good Swift interoperability at this point. So, you should use the type collection syntax and nullability tags so that we don't accidentally touch in explicitly or optional the wrong way. The framework includes a universal binary, so it gives us all the architectures we need, including the simulator one, which is often missing. And yes, we like documentation. We like to know what the framework's third-party dependencies are. So the framework's dependencies become our dependencies, and we kind of end up owning them. So we'd like to know what they are, and that way we can preempt maybe some collisions, such as if we think there might be some. And until we have ABI, application binary interface compatibility with Swift, we would prefer that serious frameworks we continue to be developed in Objective-C. I'll talk more about that later. Explain that. We depend on you to be faster than us, and what that means is that if Apple comes up with a new standard like app transport security, have a beta out for us to play with so we can include that in our cycle. Like if we care about upping the network standards of our application, we don't want your framework to hold us back. So now that we've kind of defined some standards, at least from the consumer point of view, if we want to build a framework ourselves, we begin with a new project and select a template. We have CocoaTouch framework or CocoaTouch static libraries options. And we want to think about, what the problem is, who the audience is, what language we're using, like Objective-C or Swift, basically, what ways we want to distribute it. So will we provide a link, or will we, use CocoaPods or Carthage, what our builds are, and is it going to be open or closed source? So first, I'll talk about dynamic frameworks. Dynamic frameworks were introduced with iOS 8 at WWDC 2014. And they were introduced alongside targets, like extension targets, as a way to package and modularize and share code. And the product of a dynamic framework project is a dilib that's linked at runtime. So when your app starts up, it's going to load all the dilibs that you've linked against at runtime, and then go. We've had some issues with dynamic frameworks on our projects, particularly related to our continuous integration server. So on our CI server, we found that if the build configurations of the host project don't line up with the build configurations of the framework project, when you embed that project, that the framework ends up defaulting to release. And on the build server, you'll get import errors that we can't find the symbols that hit the framework at all. And so there are a couple ways you can approach this. You can either modify your framework project, and if it's third party one, you may not want to do that because that kind of makes you have to fork it. Alternatively, you can map the build configurations. You can make a user-defined environment variable, and then change your framework search path as a workaround. Those are the ways we know to get it to work right now. Surely, if anybody has any better ideas, we'd be interested in hearing about those. We've also had code signing issues just because we work in these large teams, and we can't be a part of usually the account, like the iOS developer account. So we have to do our provisioning kind of manually, and we set that in the project. And with the framework targets, we don't really want to modify those. And so on the CI server, like we've had this problem with code signing, but with Xcode 8, we should see a remedy for that because in the release notes it says Xcode does not require code signing for iOS frameworks and will skip signing if the team is not set. So that's pretty cool. I think that's going to do what we want, and we're excited about that. At WWDC 2016 this year, there was a session called Optimizing App Startup Time. And I found this session really interesting. About 3/4 of the way through, the engineer starts talking about dynamic frameworks, and he recommends we link about half a dozen of these, not really any more than that. So six dynamic frameworks. And I found that interesting, especially because the impression I had, like people's takeaway from WWDC 2014 was this was kind of like the new one way to share code on our platform. At least I think a lot of people had that impression this was a good way to share lots of things. And it turns out, really about 6. You can actually measure the startup time of the load time of the dynamic frameworks for your app by setting an environment variable called DYLE print statistics. And if you do that, you'll sort of get feedback, on how long it took to load your dynamic framework. So if you have lots of them, you might want to try that and see what the impact is. So that's pretty much dynamic frameworks. Next, I'd like to talk about universal static frameworks. This is kind of the de facto standard for our platform. The first step to making one of these is to use the static library template, and that'll basically give you a binary. And then you'll do some process to turn that into a universal static framework. This is kind of like a community effort. There's no real Xcode support on iOS, so there's a bunch of script examples and a couple of GitHub projects that you can check out to learn about this. These frameworks are linked to compile time, so they become part of your apps bundle, your apps binary. And so you don't incur the runtime cost of linking against universal static frameworks. Apple says it would be dangerous to rely upon binary frameworks that use Swift. I think a lot of people are aware of this. It's because of the ABI compatibility story. So, Apple, at the moment, Swift is evolving, and the binary representation of compiled Swift is subject to change. So if you release a framework written in Swift right now, and something changes about the user's environment, or the user's environment doesn't match the environment you used, they're going to have to upgrade it. So this is lots of upgrading. This isn't a situation you want to be in as a framework vendor. So pretty much, if you're building a universal static framework right now, you want to use Objective-C. So Coca-Touch static libraries and Swift do not mix very well right now. It looks to me like Swift 4 is going to be when we have ABI stability. I think that the Swift 4 team will push for that, but who knows? That's just how it feels to me right now. So the process for making one of these is mostly 3 steps. You build your static binaries for the architectures you care about. You use LIGO, which is a command line tool that can concatenate those into one binary. And then you package that fat binary, header files, and any other resources into a directory that ends in .framework. And it's so easy, but it's not. Like when you do this in production with a big team, you're going to find out there's exceptions, and you're going to have to tweak it. So I get the impression that professional shops that build frameworks all the time end up putting a lot of time into their scripts for this to get it just right. So high-level overview: static versus dynamic frameworks. If you're going to base your company on it right now, build a static framework and distribute that. If you're leaning into the future with a beta that you'd like to write in Swift, then sure, make a dynamic framework. If you're anticipating large-scale use, make a static framework. If you're sharing code with an extension, so you're modularizing your own project, then make a dynamic framework. If you're writing in Objective-C and you'd like to keep your source to yourself, use a static framework. Make a static framework. If you're writing an open source Swift framework for just like general sharing, and that's just where you are, you have no other option, right? Make a dynamic framework. And static frameworks in general, result in faster runtime, startup time, and dynamic frameworks. You can use this as a tool to speed up your compile time by modularizing your app, which is really important in apps that have a lot of Swift. I think our app has 80, 90,000 lines of Swift, and it takes 14 minutes to build on the server. So it's probably time for us to revisit how we modularize that. Swift can be really slow to compile. And so one of the thoughts I'm trying to leave with right here is that runtime versus compile time performance is an engineering question that we should actively consider. We don't want to opt into all of one or all the other. We don't want to just say, all right, we're just doing dynamic frameworks and we're done, because at some point we'll probably push over a threshold where startup time is affected. So we want to kind of retain that choice and really think about what's right for our project, and we don't want that choice imposed on us. So after we wrote our first article that resulted in the checklist, we wanted to kind of put that to work. So Ada Turner, my colleague, had written a UI trait collection utility, and the theme of it, the thesis of it is UI trait environment is just too full to be limited to using view controllers. So we wanted to have arbitrary things like structs be able to participate in the UI trait environment, and I say we need to do that. And then I got involved on the packaging side, as part of our series of articles. And so we had the problem in the audience solved for us. We wanted to work with UI traits collection programmatically, much simpler. It has lots of syntax sugar. It's really great. The language was predetermined. It's Swift, so we're pretty much in dynamic framework land. And we wanted to distribute to as many channels as possible because we want to play with the community and share as much as we can. And it was definitely open source and MIT licensed. So feel free to go and check out Briggs if you're interested in working with trait collections programmatically. It's pretty cool. And the article related to this effort is iOS Framework Part 2, Build and Ship. We, of the checklist items, we really focused on the public interface. So we kind of really, speaking for Ada, Ada put a lot of time into documenting the parameters, and so we try to make a nice example for how to do that. And another thing that we took to heart that I think if you're making frameworks you should really truly care about is that when you're writing code for your own project, it's like your one line of code gets deployed into your app. When you're writing a line of framework code, that gets deployed into end users' apps, right? So you should weight, you should feel that weight. Like all those lines of code are multiplied, and you should feel that. And so that's where you could make a better case for having good test coverage. I know our platform is kind of mixed on how much testing we think we should do. Our shop definitely has a take on it, and other shops have the opposite take. But when you're doing frameworks, you could really get into making a more solid argument for testing. And if not for anything else, it's just because it's sometimes easier. Like you have a series of methods, and you can test those methods. And if you contrast that with an app that has view controllers that are harder to test, the story is much simpler. Another little story. Facebook just recently released a beta Swift SDK, which is cool, and we can play with it. At the same time, they had a pre-existing Objective-C SDK. So there's been this sort of normal way to integrate Facebook if you're interested in it. I don't know how good it is. I haven't really done the Facebook integration, but the Swift SDK is coming along, kind of late. Swift has been around a while, so we're seeing the Swift SDK arrive now. So that's interesting that Facebook has, they're an super engineering heavy company, and they've waited for a while. Contrast that with Dropbox, who released their Swift SDK beta back a year ago, and then they pulled it out of beta in November. So Dropbox didn't have an existing Objective-C SDK. Their first sort of official SDK was Swift. And the problem with that is that it sort of left Objective-C only apps kind of stranded. If apps that were trying to be guarded about Swift and keep it at arm's length, like they didn't want to bring in all the lib Swift stuff, and maybe write a wrapper. So the community kind of responded, I think, and there were a couple of non-official frameworks that were released, and just now Dropbox is kind of coming back around, and they have an Objective-C SDK due in August, due this month. So as far as what's good for our community, we definitely in this case prefer Facebook's approach. All right, so next I want to talk a little bit about distribution and package managers, and I'll just say to start, sharing is good. Code sharing is good. A lot of the efforts we've undertaken, have been enabled by the fact that somebody's open sourced a project. So we really appreciate sharing. And also the package managers that help make that happen are great for that reason. So before you do anything, you should make sure that you have a manual installation path. We don't want CocoaPods or Carthage or whatever it is imposed on our projects, because we may have a different take on that story, and that doesn't really relate to how we feel about your framework. So let's keep those, kind of separate and offer a manual installation path. First, I'd like to talk about CocoaPods. CocoaPods is absolutely the fanciest and widely popular package manager that we have for our platform. It's so popular that Google actually mentioned it in their I/O keynote in 2015. Can you imagine Apple mentioning like a Google third-party keynote? That'd be wild, right? It's also so popular that at one point they got throttled by GitHub for their trunk repository because they were getting so many hits on it. So CocoaPods is really widely used and accepted, and I'm sure lots of you use it. So that's cool. CocoaPods was inspired by the Ruby community and Bundler. So I have some experience with this, with a little bit of Rails, maybe some of you have too. And in the Ruby community, Bundler came along as a solution to help be declarative about dependencies and versions, and it works really pretty well. I think it works well enough. And this ecosystem, this Ruby ecosystem, is very, very warm about sharing, right? Like they have this fairly virtuous cycle. I haven't been out of Rails for a while, but at least the way I remember it is that the community participates a lot. It's not uncommon for a Ruby project to bundle like 30 or 50 gems. That's not a big deal. CocoaPods are somewhat trickier. The sharing story for our platform, I feel like, is a little bit more complex. We have project files and architectures to worry about, so they've had to solve those problems, and to a large extent, I suppose they've been a success as well. So basically, what the CocoaPods team wanted to do and did, is they take the Ruby sort of dependency management solution and platform roughly, and then they bolt that onto our ecosystem. And the sharing is kind of both ways too. I think the CocoaPods dependency resolver got pulled back into Bundler, so it's really kind of a close relationship there. So as a community of developers, how do we identify with regards to code sharing? I feel like, to an extent, there's a good, healthy, unhealthy, dose of non-invented here syndrome, not invented here syndrome. And so, I kind of wonder where that comes from. And I suppose at least part of it is due to risk. Maybe that's the 7-day review time we used to have, and it's a contributor. Or maybe it's that people have been burned, or that we don't have quite the virtuous cycle of giving back that the Ruby community has, to where projects aren't going to be quite as well off as the Ruby projects are here. But in any case, I definitely talk to people, and I know this is prevalent, and there's definitely not the idea that you can share 30 CocoaPods and be happy about that. I'm sure there are exceptions. So the not invented here syndrome sort of is a very me-oriented idea. So I'm definitely willing to Google and look at other open source projects, but I'm not really willing to probably put my work back out as open source or to contribute, because pretty much when I Google something, I'm probably going to rewrite it my way and then keep it to myself in my proprietary app. So it's kind of a me-oriented approach to sharing. This is Saint Nucius. He's about free speech, not free beer, so free software and free speech. This is DHH. He's definitely well entrenched in the open source community. And this is Larry. Larry's about as proprietary as you get. He looks at open source software the way Wolf looked at pack of sheep, like it's yummy, right? Like you can just have it and not necessarily get back on. So I put this slide up here because this tension, at least I feel it when I look at this slide, because these are kind of icons in my mind. This tension that I feel when I look at this it kind of helps me reason about or relate to how I feel about code sharing in our community. And so I start to wonder, where do we fit in this continuum? And where does Apple fit? Like Apple, builds and releases Darwin, which is open source, which is, probably pulls them away from the Larry end of things, And Darwin is based on FreeBSD roots, and Next as well. So Apple puts a nice big proprietary layer over Darwin, and that's what we work on with iOS. And then upon that, we build our apps. We like to share, as we're building those apps, and then our apps are of course proprietary. So where do we sit? I think the CocoaPods oriented community would like to sit more, in the middle, like kind of like right with the mindset of the average Rails developer, or with DHH. And I think that we have a good segment of our community that's really kind of more on the proprietary side of things. That's not really inclined to share. So I think that we're kind of fragmented as a community in a band, and somewhere between DHH and Larry. Nobody gets to be the same in this room. Out of here, I have some. Back to CocoaPods, now that we've kind of set a tone, or wanted to set a tone. CocoaPods is really easy to use. You basically make a pod file, and you run pod install. There's a trade-off here, though. CocoaPods had big problems to solve, and so you're going to trade your project file for a workspace file, and you're going to sort of give up control over how you link in your frameworks. And CocoaPods has two modes. So it has a static framework mode and dynamic framework mode, which is determined by use frameworks. So about use frameworks. Use frameworks is a Ruby method, and it's a Ruby method that ends in a bang. And so in Ruby land, bang methods are considered destructive. And they're usually used to mark methods that are going to change the state of your data or something like that. So it's an interesting choice, and I wonder if that's explicit. Did the CocoaPods team recognize that we should go crazy with dynamic frameworks and ended the bang methods to say this is destructive, or is it more of a declaration? Like, use frameworks. This is the the one true way now. So I kind of wonder what the thoughts were there. I actually don't know that. I suggest we rename this one. Use about 6 frameworks. Okay. This is still a valid Ruby method because the question mark. So somebody submit that PR. No, don't. Please don't. But that's I find that very interesting that use frameworks is now a canonical example on the CocoaPods website. Contrast CocoaPods with Carthage, which wants to be the simplest way to add frameworks into your Cocoa application. So Carthage is even easier than CocoaPods because you really have a one-liner that you put in a cart file, and that's it. From the point of view of pulling in frameworks with Carthage. An interesting note about Carthage is that it came out after WWDC 2014, and it only works with the dynamic frameworks. So the idea was like, hey, cool, dynamic frameworks are awesome, and they're easier to use than worrying about static frameworks. So we could build a system on top of this to share all these dynamic frameworks. They've had to do a workaround. So Carthage builds your dependencies out of your Xcode app, and Apple recommends explicitly against that. So the workaround Carthage has had to put in place is to strip out the architectures that you don't need, otherwise you can run into an issue submitting to the App Store. So that's a little bit of a hack that they've had to do, but apart from that, it's a solution for pulling in dynamic frameworks. So next, I'd like to talk about the Swift Package Manager. The Swift Package Manager is an in-progress effort right now, and it looks to be shaping up to be a really cool project. They hired Max Howell of Homebrew fame, and then I guess he left recently, and so that's kind of a bummer. That seemed pretty cool that he was on the team. But I think the team is still chugging, and so Apple is working on this problem that Homebrew and Carthage, that CocoaPods and Carthage have been working on. Package.swift files is equivalent to a pod file or a cart file in terms of intention. It's a Swift file though, so we get a little bit more natural environment to maybe be more flexible with what we do. Most of the simple examples are really simple though. You just declare that you want to have a package, and then and you run a command, and it goes and builds that package for you. And so a lot like Carthage, it builds your package, and it works right now in OS 10. So I attended the IBM session with the drone and all the server-side stuff, and they're very much into packages now. They have an index of packages, which is pretty cool. And for their server-side stuff, you can absolutely use the Swift Package Manager right now. The Package Manager community proposal says that by default, we plan to build packages as static libraries right now, which incur less runtime overhead than dynamic libraries. So this gives you an idea of what Apple is thinking in regards to code sharing. The community proposal has a lot of interesting features, and I'll put the ones up here that I think are the most interesting. Xcode integration. So maybe soon we can open up Xcode and we can just tell it whether we want that we want these 5 packages, and these three will be static, these 2 will be dynamic, and maybe this is the future that we have where we can just be declared in Xcode and we're all done. They're going to make a package index, so this feels inspired by CocoaPods. I know that's not a novel idea for CocoaPods, but I definitely see a lot of CocoaPods influencing the sort of package manager. They are going to build static libraries by default, and dynamic library support is coming soon. So there's definitely an intention to have both of those. They're going to have automated test running, and it's going to have tools to help you diagnose dependency issues. So they have a lot in progress. They just gave us an update about a week ago where they sort of gave us a snapshot of where they are. And on one hand, you might think that it was discouraging just because it's such a big list, but it feels like they're moving fast, and I still can count on that with Swift 4 we'll have something usable even with Xcode integration. So that's what I'm looking forward to next year. So high-level roundup of where we are. Because of WWDC 2014 and because of Swift's ABI stability situation, we've seen kind of a proliferation of dynamic framework sharing. And Apple says, let's use about 6 of those. And the predominant community package managers both offer dynamic framework solutions because of what the option is. Carthage exclusively, and CocoaPods is definitely pushing it, in my opinion, because it's their canonical example. And so both of these package managers come from this mindset that they want to have this super sharing culture where it's really easy to pull things, really easy to share things, and at least for CocoaPods, it's inspired by the Ruby community and the way that works. And so these ideas at the moment are incompatible, and so that's what I feel about the current state of affairs of code sharing in our ecosystem. So at the moment, for anything serious, so if you're actually planning to build an SDK, whatever it is to provide audience for your company, Objective-C and static frameworks are the option to go with right now. In a year, you can revisit it, and maybe it's time to get a beta Swift in the mix and get prepared to convert that to a static framework for when the Swift Package Manager comes online. And hopefully the Swift Package Manager wipes it all away and takes care of it. I'll leave you with a thought. Like I said earlier, we've built lots of apps this year, and we've definitely linked to lots of frameworks that left a lot to be desired. And for our part, we're kind of committed to, in our organization, pushing back to these framework vendors and saying, it's not okay for you to have warnings and to bring those into our projects. And we have a standard, and we're trying to do our best to uphold that, and still satisfy our clients and integrate all the utilities that they want. So as a community, let's build and demand quality frameworks. And thanks. I'm Sulwan on Twitter, so follow me, I'll follow you back. I'm going to make connections and meet people. Those are the 3 articles that we wrote related to the talk today. So if you're interested in reading a little bit more about what we've done and what our thoughts are, check out those articles. If you have any questions, I'm open.
You have a lot to say about dependency management and the way you do that. worry about using Git submodules?
So we use, on my team, we use Git submodules. And I feel like, versus Carthage, of course Carthage makes you use dynamic, but it's really the same story, or CocoaPods in some ways. The framework that you're including, whether it's a CocoaPod or not, it still has to be of a certain quality, it still has to not have issues. So then it becomes a matter of porcelain, right? Like the Git porcelain for submodules maybe leaves something to be desired. And at the same time though, I feel like we don't really struggle with that as a team, we pull in frameworks, we add them as a submodule, and then we update them occasionally. So all the semantic versioning and stuff that you get with a cart file or pod file, I feel like has a place, and I look forward to that. At the same time, for us, the right choice I think is submodules. Yeah.
So I have the same problems you guys have. So that all the clients we work with have tons of frameworks that they want added and integrated, and they always give the same line that it'll only take a day, and then it takes 3 months later, we're still trying to integrate their framework. F-bomb. So my question is, how do you regulate what they send you when you first start a project?
All right, so actually, back to that story. One of the things that happened during that story was that the client that I work with actually reached out and they said, "What can we do? We don't want to have this happen. We don't like to watch you live this way." So the framework checklist that we made was actually a response to that, and we passed that back to the client. And we said, "Look, if you want to save time, pass this checklist to them, and when they reach most compliance with this thing, pass their framework back to us, and I promise you we'll be faster. I don't know if we'll be still drop it in a day, but it will be much faster." And in our article, if you go back and read it, we say this is our checklist, make your own, make the framework checklist that makes sense for you, and cite the things that you care about. But that would be my advice, is to work with the client and say, hey, look, if you want to not spend money wasting time on integrating bad frameworks, have the framework authors meet these criteria first. So that's our answer at the moment.
So have you had them push back on not doing it?
We have. We've had the client present that checklist to a different vendor, and the vendor made concessions for us. We also reviewed AppTelligent's framework recently, and AppTelligent hadn't hit all of our points, and then they went to work for us and actually fixed up their framework so that they could be a part of a follow particle. So there's some traction. I've improved 3, I think. So that's next time you guys work with no notes, so you're gonna appreciate it. Anything else? Back.
So one of the biggest things that a lot of developers seem to ignore is code overhead and risk. How do you typically take an approach by identifying when code overhead justifies the risk?
Okay, yeah, so the question is about overhead versus risk. And so, that's a tough one for several reasons. But, I think, if we compare back to the Ruby community where they do tons of sharing, I think the fact that they can deploy instantly, you can usually update apps instantly, kind of mitigates some of that, and just the fact that it's such a community contribution for our platform. So for us, if we don't have the client basically saying this is going in, you can fight with the vendor a little bit, but it's going in. The story we usually tell is related to what types of things the framework is doing. So if it's swizzling, for instance, I think that's a common refrain that somebody in our team, if they're forced to put in a framework that swizzles a lot, they're going to push back a little bit more than say something that's just maybe unnecessary or cruft. So I think first we try to assess is this thing that we're being asked to put in actually harmful to the app, or is it just unsavory, right? And if it's just unsavory, we might comment about it, and especially if it has warnings, we're definitely going to say something and say we need it to be clean, even though we don't particularly like it. But if it's actually harmful and it actually has performance impacts, we'll try to build a story around that. So we'll come back to the client and say, look, this is going to slow down your app, or this is going to affect the performance negatively in other ways, or this is bad for your users. or it's just does bad things in the system that might cause crashes. And so we try to build a case to our clients, and push back that way. So as far as evaluating risk, I think we try to like understand what the risk is, and then after that, we go from there. As far as like on a personal project, I think that I recognize that at least until Apple gets involved, we're not Ruby. And so, Justin Williams talked the other day ago about his choices, and he said, they like to keep their dependencies kind of manageable, and for the TED app, they have about 7. And so I guess that sentiment kind of resonates with me, that, about 7 feels right.
So what if you have one like REST?
So if you want to use RESTKit, and RESTKit is written in Swift, correct? It's like a full Swift.
I actually don't remember if they updated it or not, but it's very robust. It does very many things, and it abstracts a lot of different layers.
Yeah. So I think for our shop, we try to not depend on things that are very heavy-handed, just because that feels risky. And so another thing to consider too is how many people you have on your project and how many people migrate between projects. So we have these big projects, that have like ramp up to 12 people or 13 people in one day, and then the next week they cool off and they go back down to 4. So maybe in the next couple weeks, maybe a few sprints. So in that particular case, trying to train a team on a framework that has a very particular take on the world, that's very mobile throughout several projects, is really difficult. So we try to keep things fairly vanilla. That being said, we don't want to reinvent the wheel. So if there's something that solves a good problem, then we're willing to use it. Or something that we know that's community reviewed that gets things right, we're definitely willing to use it. Anything else? Questions? All right, I think that's it. Thanks, everyone.